Assalamualaikum and hi everyone. Thank you for joining me today. My presentation centers around a topic of great importance in the field of education, machine learning for predicting students' academic achievement based on learning style and academic result. The search of big data provides novel approaches to managing it. Conventional approaches and productivity utilities are incapable of handling and assessing extensive data. Enterprise leaders need to embrace innovative technologies and methodologies like machine learning that align with their information requirement to leverage big data's potential. This knowledge can be applied to both educational and production setting to assist decision makers in achieving the highest level of precision. To guarantee the timely graduation of students, educators must take the lead. Utilizing machine learning, this research examines the correlation between student achievement and outcomes, learning preferences, individual traits, and parental approaches. The objective of this study is to explore the viability of utilizing machine learning methods in forecasting students' academic success by examining their unique approaches to learning. The study aimed to explore the relationship between student achievement and a range of factors, including learning preferences, individual traits, and parental involvement. By harnessing the power of machine learning, educators can gain valuable insight from extensive data sets. These insights can inform decision-making processes and contribute to the timely graduation of students. Additionally, implementing innovative technologies and methodologies aligned with information requirements allows enterprises to unlock the full potential of big data and optimize productivity in both educational and production settings. For literature review, based on the previous research outcome presented by Sandra and her team in 2021, it has been established that students' future academic performance can be predicted by analyzing their past academic records, including grades, and considering factors such as their unique learning styles, personalities, and parental involvement. While Yak in 2022 further delved into this area and devised a method to estimate students' final exam scores using midterm result. To validate the accuracy of this prediction, the author employed various machine learning techniques. Chauhan et al. 2019 suggested an enhanced aspect wherein an accomplished individual in a particular subject are designated as tutors. So these tutors could be classmates or senior students. Along with tutor information, they considered the dataset encompassing previous academics outcomes for predicting performance. So their findings indicated that the multiple linear regression model offers the most favorable solution. Zohar 2019 conducted a study aimed at assisting vulnerable students and ensuring their continued enrollment. The objective was to establish a reliable accuracy rate within a limited dataset. The research involved investigating the potential identification of significant factors within the small dataset. These factors would then be employed to construct a predictive model, leveraging visualization and clustering algorithm. The finding of the study demonstrated the effectiveness of support vector machine and discriminant analysis algorithm in training small datasets and achieving satisfactory rates of accuracy and reliability in classification tests. Dilipan et al. 2021 presented a model that utilized students' 10th, 12th, and prior semester performance to assist them in identifying their ultimate grade and boosting their academic behavior. The study employed binomial logistic regression, decision tree, and entropy, and also KNN classifier method. Alta-Brawi et al. 2019 emphasized the importance of proactive support and suitable measures to enhance student performance and achieve their goals. They use four machine learning techniques to forecast student performance in computer science subject, considering the impact of time spent on social network. Their fully connected feed-forward multi-layer NN showed the most promising result, achieving performance scores of 0.807 and the highest classification accuracy 77.04% among all models tested. And last one, Pingrich et al. 1983 conducted assessment of the MSLQ questionnaires reliability and validity, revealing that both the general framework and the scale serve as valid and reliable instrument to evaluate students' motivation and classroom learning strategies. In this study, the MSLQ and students' past academic performance were analyzed to forecast their future achievement. The extracted data for the Sistem Pengurusan Maklumat Polytechnic (SPMP) serve as a valuable resource for this research. So it provides comprehensive student record that are stored on a server situated at PKS. So this centralized information hub enables efficient access to crucial data, facilitating the analysis and exploration of various educational aspects. With a wealth of record at our disposal, our investigation aims to delve deeper into pertinent factors that shape student outcomes and contribute towards enhancing the educational experience at PKS. The data we possess consists of semester outcomes, SPM's result for English and Mathematics, and the MSLQ. Okay, next is method and data sets. So as you can see, the figure presented us steps in machine learning. The process of feature selection entails reducing the number of variables employed in forecasting a specific result. So the aim is to enhance the model comprehensibility, decrease intricacy, improve algorithmic computational efficiency, and also prevent overfitting. Furthermore, the selected features undergo a rigorous evaluation process to ensure their relevance and effectiveness in achieving the desired outcome. So this evaluation involves various statistical techniques such as correlation analysis to assess the relationship between each feature and the target variable. By identifying and retaining the most influential attribute, the overall predictive power of the model is maximized, allowing for accurate and reliable forecasts. Once the feature selection process is complete, attention shifts towards developing an appropriate modeling technique. Several algorithms are considered, each with its strength and limitation, catering to different types of data and prediction tasks. Whether it be regression, classification, or clustering, the choice of algorithm heavily depends on the nature of problem at hand. In order to ensure the chosen algorithm performs optimally, model training is conducted using a well-curated dataset. This involves splitting the available data into training and validation set, allowing the model to learn from the training set while validating its performance on unseen data. Iterative refinement techniques such as cross-validation are often employed to fine-tune model parameters, prevent overfitting, and improve generalization capabilities. Once the model has been adequately trained, it is ready for deployment and utilization. Through the application of new and unseen data, the model predictive capabilities are put to the test, providing valuable insight and enabling intelligent decision making. So, continuous monitoring and evaluation of the deployed model performance ensure its accuracy and effectiveness in real world scenario, as you can see in the previous figure. I did mention on MLSQ previously. So MLSQ is Motivated Learning Strategy Questionnaire. It was created for researchers to gauge student motivation and learning strategies, and for instructor and student to evaluate motivation level in study techniques in a particular course. In our case study, to assess students in Diploma of Digital Technology. So students assess themselves using a 7-point Likert scale ranging from 1, which is not applicable to me at all, to 7, very applicable to me. So to obtain score for specific subcategories, the average of the items within the particular subcategory is calculated. So in MLSQ, there are 7 components: motivational belief, self-regulated learning strategies, self-efficacy, cognitive strategy use, intrinsic value, self-regulation, and the last one is test anxiety. Okay, so next comes to results and analysis. So the Pearson product's moment correlation coefficient, often referred to as the Pearson correlation coefficient, is a metric that gauges the intensity of linear connection between two variables. So as illustrated in figure shown, specifically in the Pearson correlation metric, there is a notable correlation between motivation and strategies. The previous outcomes for mathematics in the SPM exam demonstrated an inverse relationship with both level of motivation and employed strategies. According to the finding outlined in the study conducted by Polychronia et al. 2012, it is evidence that students' attitude towards their classroom and overall school environment play a pivotal role in influencing their drive to excel in the subject of mathematics. This emphasizes the significance of cultivating an environment that fosters positivity, engagement, and a sense of purpose within educational institutions. When students perceive their learning environment as supportive and conducive to their academic growth, it substantially bolsters their motivation to tackle mathematical challenges with vigor and determination. Furthermore, it highlights the importance of implementing effective teaching methods and strategies that not only transmit knowledge but also inspire a genuine interest in the subject matter. So, this is according to Liu et al. 2022. In light of this insight, educators and policymakers should consider how they can proactively shape the learning environment to nurture students' motivation and enhance their strategies for approaching mathematical concepts. By doing so, we can pave the way for improved outcomes in mathematics education and equip students with the tools they need to succeed, not only in the exam but also in their future endeavors. For data preparation, data preprocessing is a critical phase in the machine learning pipeline that lays the foundation for accurate and reliable model training. After gathering the dataset, the next step is to clean and prepare it for analysis. This involves a series of steps aimed at ensuring the data is in a format that the machine learning algorithm can effectively learn from. One of the initial steps in the data pre-processing is handling missing value. This can be done through techniques like imputation, where missing values are filled in using the mean, or mode of the respective feature. Alternatively, in some cases, dropping rows with missing values might be appropriate if the amount of missing data is negligible. Next, categorical variables need to be converted into numerical format. This is achieved through techniques like one-hot encoding, which create binary column for each category, or label encoding, which assign a unique numerical label to each category. This transformation ensures that the machine learning algorithm can process the data correctly. Standardization or normalization is another crucial step. This involves scaling the features so that they all have similar scales. Outliers can significantly impact the performance of machine learning model. Identifying and handling outliers is essential. Finally, the dataset is typically split into training and testing sets. The training set is used to train the model, while the testing set is used to evaluate its performance on unseen data. This helps in preparing the dataset for machine learning, involve handling missing values, converting categorical variables, standardizing or normalizing features, addressing outliers, selecting relevant features, and splitting the data into training and testing sets. A well-prepared dataset set the stage for effective model training and ultimately leads to more accurate and reliable prediction. A snapshot of the dataset is shown in figure shows on the screen. A distribution or density plot illustrates how data is spread across a continuous range. It resembles a smooth version of a histogram and provides a visual representation of data distribution over a continuous interval. Consequently, a density plot offers insight into the likely distribution of the entire population as well. As shown in figure, the dataset is not normally distributed for our case study. So following this, the subsequent phase involved constructing a machine learning framework. In our investigation, we employed various algorithms including linear regression, decision tree regressor, random forest regressor, lasso and ridge to forecast student achievement. Each of these models brings distinct strength to the predictive process. Linear regression offers simplicity and interpretability, while decision tree regression excel in capturing non-linear relationship within the data. Random forest regressor, on the other hand, harnesses the power of ensemble learning to enhance prediction accuracy. Additionally, lasso-enriched regularization methods introduce a layer of robustness against overfitting, further refining the predictive capabilities of our model. By employing this diverse set of algorithms, we aim to comprehensively analyze and understand the factors influencing student performance. This multifaceted approach not only enrich the accuracy of our prediction, but also provide valuable insight into the complex dynamic at play in the realm of education. So the table shows the comparison among the five selected machine learning models used in this study: linear regression, decision tree regressor, random forest regressor, lasso and ridge. So among these models, random forest and ridge model exhibited the lowest value for all three metrics. This indicates that this model provided the most accurate prediction on average. Visualize the machine learning model. So analyzing figures 567 and 567, 8, and 9, it is apparent that there are not substantial differences among the four machine learning model in terms of graph visualization, with the exception of the lasso model. So the lasso model might have a different pattern in its prediction, suggesting a distinct approach to capturing the underlying relationship within the data. So to further validate the model, it's imperative to compare the actual and predicted values. The visual representation allows for a different assessment of how well each model align with the observed data. A close match between the predicted and actual values will indicate a robust predictive capability, while discrepancies may highlight areas for improvement or further investigation. And we validating and visualize between the random forest and the ridge model. The ridge regression line hugs the data point closely, indicating a stronger linear relationship between the predicted variables and the target variables. We can see that the ridge regression line fits the model more accurately than the random forest line, as shown in the figure. Upon closer examination, it's evident that random forest lines exhibits more fluctuation, reflecting its inherent ability to capture complex interaction within the data. However, this complexity also leads to a slightly less precise fit to the data compared to the rich model. The trade-off between complexity and accuracy is a fundamental consideration in model selection. So in conclusion, the comprehensive evaluation of these machine learning models suggests that random forest and rich models outperform the others in terms of predictive accuracy for predicting students' performance in JDMK PKS. However, the choice of model should also consider other factors such as interpretability, computational efficiency, and the specific requirement of the problem at hand. Moving forward, it may be beneficial to explore ensemble methods or fine-tune hyperparameters to further optimize model performance. Additionally, conducting cross-validation or assessing models on an independent test set can provide a more robust evaluation of their generalization capabilities. This step will contribute to building a reliable and robust predictive model for the given dataset. So, thank you everyone. That's all from me.